Hey friends, we're just gonna do a little review of expressions things before we move on to equations. Okay, so we're gonna start with like terms. Remember that a term is just like one little part of an expression or equation. If you think of like expressions, we have those in like when we talk, right? A term is like one word in an expression, so you can kind of think it that way. So it can be a variable by itself, just a number called a constant, or a variable with a number that's its coefficient. It's like here, this is a term, 3 is a term, and 4x is a term. So there's 1, 2, 3 terms in this expression. I'm going to zoom out a little bit. Make it a little easier for you. Okay. On this one, there's 1, 2, 3, 4 terms in this expression. Okay. And like terms are terms that have the same variable, or constants can be like terms with other constants. So in this example, 7x plus 3 minus 4x, 7x and minus 4x are like terms because they both have an x. Okay, notice I circled this minus with the 4 because he goes with the 4, so those belong together. Okay, so y minus 10 plus z plus 12.9. The like terms in this one are the constants, so we have a minus 10 plus 12.9 are like terms because they don't have a variable. Y and z are not like terms because they're different letters. They're not the same thing. So to simplify, by combining like terms, we're going to add or subtract whatever we can. So first I have to identify the like terms. So 7x and minus 4x are like terms. Okay. So I'm going to take their coefficients. The coefficient of 7x is 7, and then of minus 4x is minus 4. Okay, and I'm just going to add or subtract their coefficients. So I'm going to do 7 minus 4 and get 3. So this simplifies to 3x. And I still have to include this plus 3. Okay, but I have to stop there. 3x has an x. This 3 is just a constant. It doesn't have an x, so I'm done there. So I get to stop. Okay, I'll grab another color real quick. Okay, so 2z plus 12.1 minus x minus 4.8. Okay, I have to circle the like terms. 12.1 and minus 4.8 are like terms. Okay, so I'm going to do 12.1 minus 4.8. Which is 8.1. Whoops, just kidding. 7.3, that seems better. Okay. Now with the other ones, like this 2z or this minus x, I still have to include them. Okay, so in math, we're going to go in alphabetical order. So x is going to go first, and this minus goes with it. So we have minus x, and then we have 2z, so that's a positive, so we're going to plus 2z. And then when I, did 12.1 minus 4.8, we got a positive 7.3, so plus 7.3. Hey, that's kind of pretty. Those colors look nice together. I'm here for it. Okay, so we just go in alphabetical order by the variable, and then constants go at the end. You could rearrange it a different way, and you get the same thing, but this is just like nice to look at, you know? All right, so if you see problems that look like this, it means you're going to distribute. Okay. There we go. So distributing is where I take the number on the outside and I multiply it by each term. So I'm going to do 3 times x. And remember, if it's just a variable by itself, there's an invisible 1 that goes there. Then I'm going to do 3 times 9. Okay? 3 times 1x is 3x. Remember that to multiply, you don't need a like term, you can just multiply. Okay? 3 times 9 is 27. And since that's a positive 27, I can write plus 27. Okay? I have to stop here. This one has an x, this one doesn't. They're not like terms, so we're done. Okay? Even with a negative, you can still distribute. So I'm going to take my number on the outside times the first term, negative 2 times 1x. And the number on the outside times the second term, negative 2 times 7. Okay. Negative 2 times 1 is negative 2, so we have a negative 2x. Negative 2 times 7 is a negative 14, so I can write that as a minus 14. And remember, when we do it this way, where we include this sign with the second term, it lets us skip that keep change step. That's why that's happening. Okay? So I'll show you here. So we're going to take 7 times 2x. Then we're going to take 7 times this negative 4. This minus goes with the 4. And by doing that, I'm skipping that keep change step. Okay? So 7 times 2 is 14, so we get 14x. 7 times negative 4 is negative 28. So see how when the minus goes with the 4, this minus stays with the 28. Then I'm done. One has an x, this one doesn't have a variable, can't combine them. Okay, we're going to do negative 5 times 5x. We're going to do negative 5 times negative 9. Negative 5 times 5 is negative 25. Negative 5 times negative 9 is a positive 45. So that's what happens when you do that. You don't have to go through all that work to get it to be positive. When you keep this sign with the 9 right here, it helps you right there. All right, so factoring. Similar to simplifying fractions, that's how I think of it. So I'm going to make a factor tree between 15 and 20. I am going to list all of the things that evenly multiply to be 15. So 1 times 15, 3 times 5, 5 times 3, but I already have a combination of 5 and 3 right here, so I don't have to rewrite it. And once you start repeating factors, you can just be done. So same thing with 20. 1 times 20, 2 times 10, 4 times 5, and we'd have 5 times 4, but I have that listed already, 5 and 4 together. So I'm done. So now the biggest number that both of them have is 5. So their greatest common factor is 5. Okay? So I'm going to do 15y divided by 5. 15 divided by 5 is 3, so we're left with 3y on the inside. So we pull out a factor of 5, and you're left with 3y. Then when we do 20 divided by our greatest common factor of 5, you're left with 4. So so plus 4. So the answer to a factoring problem looks like the start of a distribution problem. Okay. All right, 30k minus 10. Find the factors of 30 and 10. 1 times 30, 2 times 15, 3 times 10, 5 times 6, and then we start repeating. For factors of 10, 1 times 10, and 2 times 5. That's it. So the biggest number that both of them have is 10. So I'm going to take out a factor of 10. Okay, and why I like to do the factor trees is because it tells you when you take a factor of 10 out of 30, you're left with 3. When you take a factor of 10 out of 10, you're left with 1. So it's right next to it. Okay, so when I take a factor of 10 out of 30k, you're left with 3k. When you take a factor of 10 out of 10, you're left with 1. So 3k minus 1. Okay? So you can factor out negatives. I'm going to not think about the negative first. So negative 2j plus 32. I'm just going to do 2 and 32 to start with. The only factors of 2 are 1 and 2. Factors of 32, 1 times 32. 2 times 16, 4 times 8, 5, 6, 7, nope. And we have 8 times 4. Okay, but we already have that combination. So the biggest number they share is 2. Okay, but since this is a negative, I'm going to take out a negative 2. So I have negative 2j divided by negative 2. Leaves me with the positive 1j. I'm going to take out negative 2. We're left with 1j. Then I have a positive 32. So I'm going to do 32 divided by that negative 2. It's going to give me negative 16. So minus 16. So that's it for expressions. Hopefully this was helpful. Let me know if you have any questions, and we're going to start equations soon, so get excited.